Welcome to episode 8 of Data Every Day. Today we will be building a classifier for SMS spam from scratch. So let's get into it. Take a look at the dataset and you can see that it has two columns plus some extra columns that we don't need. One column is a classification of ham or spam, which is spam or not spam, and the second column is a list of emails. So each entry is an email. So we can get started by importing our normal libraries. Just make this full screen. Give me 1 second. Actually, I want to just resize this. All right. So let's get our NumPy in here and our pandas. Alright, so let's just comment this a little. This is data. Then we're going to have some NLP libraries that we're using today, well, first we're going to need regular expressions, so import RE. And then from the natural language toolkit, nltk.stem, we're going to import the Porter stemmer. This will help us trim the words down so that they're more easily recognizable by the computer. Then from the natural language toolkit .tokenize, we're going to get word tokenize, which is a function that will break a string of words into its constituent parts. Then for our pre-processing section, we'll be using sklearn's label encoder and sklearn's train test split. So I didn't put encoder there. Label encoder will allow us to convert text labels like ham or spam into numeric labels so that we can feed it into our learning algorithm. Then for our modeling portion, we will have we're going to use a support vector machine to classify. So sklearn.svm import svc, and we're going to need a metric other than accuracy today, because there's actually only 13% of our training examples are spam. So we have skewed classes, not 50-50. So accuracy would be a poor metric, because let's say in the case of 99% not spam and only 1% spam, then if we guessed not spam 100% of the time, we would have 99% accuracy. So we need to use a different metric called the F1 score, or F score, which will be more, it would take into account our performance in each class rather than just overall dataset. It's a metric that combines precision and recall to give us a better understanding of how our model is doing. Alright, so we'll import all of that, and then we will load in our data with pandas read CSV, and the CSV files are here, spam.csv. Just copy that, paste it in here. Oh, what happened? Oh, yes. We need to specify the encoding here, because the CSV file has some strange things. So Latin 1. Okay. Alright, so we'll take a look at the data, and we can see, alright, we have 3 unnecessary columns, so let's just drop those. We can do that with data.drop, and we will use list comprehension here to do data.columns call for call in 2, 3, 4. So basically this is saying we're going to drop the second, third, and fourth columns, right? The columns with these indexes. And so we're going to make a list consisting of the actual data.columns indexed at each of these elements. So this list will have one of these for 2, one of these for 3, one of these for 4. And each time it will return the full column, which we can then drop from the dataset. Alright, and then we can do in place is true. So now we look at the data. Those guys are gone. Now what's left is let's turn v1 into numerical data. So we're going to use the label encoder for that. Encoder equals label encoder. And the first column, or v1 column, will be encoder.fitTransform, that column. So what that'll do is take this, find all the unique values, in this case there's only 2, ham or spam, and it will assign a numeric label to each one of those unique values. So if we can also get the class mappings by creating a dictionary, index and label. For index and label in enumerate, encoder.classes. So encoder has a attribute called classes, which is a list of all the classes that are present in v1, and we're basically creating a dictionary that's going to index each one of those classes and show which class is getting assigned which value. So if we run that and then we check out class mappings, we can see, okay, so we've assigned 0s to ham and 1s to spam. So if we look at the data, 0s and 1s now, and a 1 indicates spam, a 0 indicates not spam. Alright, so now we're going to have to define a series of functions that will help us in cleaning up the dataset and making it processable by the computer. Because right now we have a bunch of strings. We need to break it down into a feature vector that we can create a matrix out of for our x. So we'll start by creating a function that's going to take an email string, and it's going to convert it to a list of stemmed words. So by stemmed words, I mean it's going to take off endings like walking, walked, walks. All those words will become the same word, walk. It'll just cut the stem off. No, it'll cut everything but the stem off. So every word will become its stemmed form. And then in addition, we're going to cut out any unnecessary characters like punctuation or email addresses, or we're going to use regular expressions to completely process the email and make it into a very simple form. So to do that, let's create a function. We can call it process email, and it's going to take in contents. Contents is just going to be a string like one of these. So this is an example of contents. And so we will start by creating a list of word indices. Oh wait, excuse me, that's not correct. Alright. No, we're going to start by creating a pointer stemmer. So PS is pointer stemmer. That's just the object that's going to help us stem the words, which we imported right here. Okay. So now contents, we're going to do a lot of processing to contents. Contents is the string of the email contents. So first we're going to lowercase it all. That's straightforward. Just going to make everything lowercase. Then we're going to use regular expressions to do a series of manipulations to it. So first, regular expressions dot substitute and raw string. We're going to specify a regular expression regular expression that looks like this. And I'll break it down in just a second. What it's saying is we're going to oh wait. Hold on. Give me 1 second, okay? I may have left something out here. Okay, yeah, I did. Alright, so there should be this here. Okay. So what this is saying is it's going to look through our contents and find if there's ever a less than sign and a greater than sign with anything other than less than or greater than signs in between. So what this is really saying is HTML tags. If it finds an HTML tag, because a lot of emails might contain HTML tags, it's just going to strip it down, it's going to take it out and replace it with a space. Okay, so we're going to take an HTML tag, anyone that finds, and we're going to replace it with a space. And we're going to apply that to contents. Alright, next we're going to have another regular expression that we will have another raw string, and we will specify this will be any number from 0 to 9, any number of times. So basically any number will be replaced with the word number. And this will just help the computer, you know, we want all numbers to look the same to the computer, just so the computer knows there's a number there. And so contents, and then we're going to do the same thing except for URLs and email addresses. We don't care what the URL is, we just want the computer to know that it's a well, we want the algorithm to know that it's a URL or an email address. So in the case of a URL, we will use that by creating a capturing group with HTTP or HTTPS. So that's saying first, if you find HTTP or HTTPS followed by a colon, followed by 2 slashes, like any URL, and then followed by anything but white space. The backslash s means white space. This is anything but, and this is finding anything listed inside. So this is saying if you see a URL, find this, and then everything until you find white space, and any number of times. And we're going to replace it with HTTP address. Okay, and we'll do the same thing for email addresses. So here we will say if you find anything but white space followed by an @, which is then again followed by anything but white space any number of times, we'll just replace that with email address. And last one we'll do is any $signs, because obviously $signs could be used in spam quite a bit. So it's saying if we find a $sign any number of times in a row, we'll just replace it with $. Okay, so this is quite a good cleanup of our email contents. Now what we're going to do is use the word tokenize function, right here, word tokenize, to take the content string and break it down into individual words. And so we'll make a list called words. We'll use the list comprehension to say it will be consisting of some number of words where each word is a word in word tokenize contents. Alright, so this is saying let's tokenize the string, let's break it down into individual words, a list of individual words, and then we're going to take each element of that list and put it into this list right here. Right. Why did I do? Couldn't we just? Whatever. I'll keep it as it is. Let's see. Actually, I want to try this. For words, we'll just equal this, because it should be the same thing. Okay, so for I in range length of words. So now we have this new list of tokenized words, So it's no longer a string, it's now a list of words, or list of strings. And for each one, we're going to give it for each one, word sub I, we're going to give it one more round of cleaning, which we're just going to have, let's remove anything other than A to Z, capital A to capital Z, or 0 to 9. And we're going to replace that with nothing. And the reason we didn't do this before is because if a word ended with something like this, and we replace it with nothing, well, I assume we might run the risk of bringing two words together. I'm not sure though. Either way, this will work. So word sub I, we're going to substitute anything but these characters with nothing and apply it to that word. Then we're going to stem the word. So now it's been totally processed. We'll stem the word by saying ps.stem word sub I. Okay. So now for each word in words, we have stripped out any unnecessary characters and stemmed the word. And now we're just last step. We're going to remove any blank words that have no characters. So we'll say words is now equal to a list where each item is a word for word in words if the length of the word is greater than or equal to 1. So if for each word, right, for each word in words, if the length is greater than or equal to 1, we're going to add it to this list, words. Alright, now once that's done, we can return words. So there we go. Now if we can just, let's get a sample email. So I have an email sample here. Let's call it email. There's going to be triple quotes, and looks like that. Okay, so unspecified if this is spam or not, but we're going to go ahead and check it out. So if we run this process email on it, it should return us a list, right? A list of fully processed words. So process email, email. Fantastic. And you see, so this takes all the words. Anyone knows how much it costs. Anyone know how much? You see, it stemmed the word by taking off any endings, and it has removed any punctuation. Also replacing any email addresses with email address, dollars with $num. Well, actually, that might be part of it, is it? Oh wait, no, it's $num. So interesting. That counts it as one word. Okay. Well, anyway, HTTP address. You can see it's just completely processed that. Okay, so we have that. We can let's just bring this up here. Make our next function. So now that we have a function that can process an email, we're going to try to get a vocabulary list. So in order to train the spam classifier, it needs to know what kind of words are found in spam and what kind of words are found in non-spam. So if we create a vocabulary list of the let's say 2,000 or so most common words in all of our emails, then we can use that list to create a vector of features where each value is the presence of a vocabulary word in a given email. So let's go ahead and make a function which will take a list of emails, and it will get a dictionary of the most common words. So we'll call that getVocabulary, and it will take in a list of emails and the length of how many vocab words we want to include, which we'll call vocab length. Alright, So we'll start off with our vocabulary. It's going to be an empty dictionary. And we're going to say, okay, for each email, we're going to process the email with our process email function. And we're going to basically count up the every word, how many times is every word said across all emails. So given a bunch of emails, let's find all the words and find the most common words that are present. So we can start by just saying for I in range length of emails. So this means for each email, we'll say email sub I, process email sub I. So we're going to process each email in our list of emails. And for each word in this particular email, in emails sub I, so for each email, we're going to process it, and then for each word within it, or each word within the processed version of it, we're going to check if the word is in our vocabulary already. So if it's in a key, if it's being used as a key, then we're going to increment its value by 1. So this is saying if the word is already in our vocabulary, right? If it's been seen before, we're going to increment the number of times it's been seen by 1. Otherwise, which means it has not been seen before, we're going to set the number of times it's been seen to be 1, because we've only seen it once. So at the end of running this, what we should have is every word that's found in any email will be associated with a number of times that it's been seen across all emails. Okay, so now we have a vocabulary, which is this dictionary, and we're just going to, first of all, we want to, we're going to want to sort it so that we can get the most common words first, descending down to the least common words, and then we want to chop it off at vocab length so that we can get the proper length of the dictionary. So first we will sort it. Vocabulary equals sorted, which is a nifty Python function, vocabulary.items. So we're doing this in a bit of a strange way. I'll explain it in just a sec. Okay. So basically, all right, let's say we have a dictionary. Okay, X, we'll call it. X is going to be, we'll say A is mapped to 2, B is mapped to 5, and C is mapped to 1. Okay, here's our X. Now, if we try to sort it, sorted X, yeah, I'll put it on separate ones. Here. You can see all we get back is the values. Now, we actually want the keys too, because, or rather, we're actually only getting the keys. Okay, but we want the values too, because we want, first of all, it's sorting it by key. See, it doesn't actually care about the value here, 2, 5, and 1. We want it to be sorted so that C comes first, A comes second, and B comes third, because it goes 1, 2, 5. Or rather, we'd want it in descending order. But we want to sort by value rather than by key. And the way that we can do this is by saying x.items, first of all, x.items looks like this. It becomes a list of tuples of the pairings. So with that, we can say sorted x.items. Now if we do this, you can see it did exactly the same thing it did up here, but now we can have both values. Now we're going to specify a key argument, which is saying, okay, this is going to be a function which will take what we normally use as the key and use something else as the key. So we'll create an anonymous lambda function which will take our normal key, x, and return, this is confusing, let's make this not x, let's make it z, okay. It's going to take our normal key, which we'll call z, and it's going to return, instead as our key, we're going to use z subscript 1. So this is saying, normally, our key would be this, which turns into just looking at that. But we're going to take this, and instead of using this whole tuple as our key, we're going to use the key subscript 1 as the key. So we're going to use 2, because this is a tuple subscript 1. So by doing this, we can effectively sort by value, because now the key is actually the value instead of the initial dictionary key. So if we include the reverse equals true, you can see it'll do it backwards. This is exactly what we want. We want the most common words with the highest count at the front, descending down until the least common words. So we'll do that right here. That's what this is doing. And so once that's done, we're going to chop it off at vocab length, the length of the vocabulary specified. Because currently this whole vocabulary dictionary is going to be as long as there are unique words in all of the emails. So that's going to be really long. So we want to chop it down to the number of features that we want. So vocabulary equals, okay, convert to a list. Well, actually, give me a second on that. Basically, we're going to take vocabulary from 0 to vocab length. Okay. However, if you think about this, vocabulary right now is looking like this. It's actually a list of tuples. And we don't want it as a list of tuples, we want it as a real dictionary again. So we're going to have to turn it back into a dictionary. So, to do that, we will map it to a function that will do that. So, we'll map, and the function that will map to it is going to be, it's going to be another lambda function that will take in an x, or x here being every value of this list of tuples. And instead, the transformation we're going to apply to each value, we're going to make it equal to only its first element. So every tuple is just going to become its first element. So now that it's sorted, we don't have to worry about these guys anymore. We just want to strip it down to just the word. So, right, we'll map that lambda function to it, and then we will convert this to a list, because currently it's a map. Okay. And then the last thing we're going to do is we're just going to turn that list back into a dictionary. This way we can give each word a unique identifier. So index label, no, index word will do. Index word in vocabulary. No, sorry. Index word for index and word in enumerate vocabulary. Excuse me. So this will just convert it back to a dictionary, very simply. Then we will return vocabulary, and we will see what this does. So, alright, cool. So let's say, okay, we have data, right? Data v2 is basically our list of email strings. So data v2, it is a list, well, really a data frame, but we can do two lists to get it into a list form. And this is a list of emails, where each email is represented by a string of its contents. So this looks like a great thing we can pass right into get vocabularies, because emails is supposed to be a list of strings. So let's do that. Let's get vocabulary. It'll take emails, and we'll specify a vocab length. Let's say 2000. And if we look at what that will give us, this is going to take some time because, well, there we go. These are the 2000 most common words found in the emails. And you can see I is number 1, any sort of number is number 2. All the most common words you can see make sense. But 2,000 of them, I mean, eventually we're going to get to some weird ones. Sunshine is 991st most common word. Alright, so we're really getting somewhere here. Now what we're going to do is we're going to get the indices, these things, basically for a given email. We're going to check each word in that email and see if it's in our vocab list. And then if it is, we're going to record the index of that word. So each email will be associated with a list of vocab words that are found in the email. So we'll make a new function that will get the indices of vocab words used in a given email. Okay. We'll call that get indices. Email vocabulary. Okay, so it's going to look through the email, and then it's going to check all the words in that email against words in the vocabulary, and it's going to see which are used, and then it will return a list of all the indexes of vocabulary words that are used. So before we write this, we're going to need another function, which a very simple function. Basically, now get a dictionary key given a value. Because Python doesn't give us a way to do this by default. Normally you can only get a value given a key. So we'll just do a get key, which will take some dictionary and some value we're searching for. And then for each key and value pair in the dictionary, if the value is equal to the value we're searching for, we will return its key. So very simple. Given a value, we'll get a key. Okay. So now we're going to get a list of the indices used. The indices of vocab words that are used. So we'll say word indices is going to be an empty set because we don't care about duplicates. And then for each word in email, right, for a given email, we're going to check for each word in it. Remember here email is going to be a processed list of stemmed words. So it'll be a list. So we'll be able to say each word in it. If that word is in vocabulary.values, in other words, if that word is on our vocab list, then word indices is going to get a new element, which will be the key, the get key, of that word in our vocab list. So this will be, it'll start off empty, and then every time we find, for a given email, every time we find a word in that email that's in our vocabulary, we're going to add the key associated with it. Return word indices. So if we have a sample email called email, right? Yeah, this is our sample email. And let's say we're going to get a vocabulary. So vocabulary equals get vocabulary. Actually, we already did that. Let's just call this vocabulary. I'll bring that down here actually so we can see. Alright, so now this is called vocabulary, and we're going to find the indices of every word in here in vocabulary. So we're going to do get indices of the email and our vocabulary. So it's going to check every word in here. It's going to check if each word is in vocabulary, and it's going to return all the indices of those words. Cannot unpack non-iterable int object. Oh, we didn't process email. Email's still a string. So looks good. Okay, let's just use process email on it. Email equals process email. So now email should be a list, right? Okay. Now we'll use it. And oh, that's not the problem. Okay, what's the issue? For key value in dictionary. Oh, it's in get key. We have a problem. For key value. Oh, yes, sorry. Not dictionary, dictionary.items, which will return the list of tuples. So now let's try it. Alright, so these are the indices of every word in our vocab list that's used in our sample email. So this is very useful because now we can design a feature vector consisting of the presence of different vocab words based on these indices. So let's write one last function, which let's just close this out. Okay, one last function that will be called getFeatureVector, and it will take in a list of word indices and our vocabulary. Okay. Okay. You know, actually, I'm pretty sure we can do this just with vocab length. Yeah. All right. So featurevec is going to be, we're going to initialize it to a NumPy array of all zeros of length, vocab length. Okay. So it's just going to be, in this case, vocab length is 2,000. So it's going to be a 2,000 long, 2,000 item array of zeros. And simply we're just going to say for I in word indices, so for each index that we found, the featurevec's ith index will equal 1. So normally it's all zeros. And now if, remember, this is going to be, each element of featurevec is going to represent a vocabulary word. If it's not present in the email, it'll be 0. And if it is present in the email, it'll be 1. So this word indices is going to be associated with a given email, and our feature vector is going to be a vector of zeros and ones, where 0 means that a particular word is not found in the email, and 1 means that particular word is found in the email. So we started off at all zeros, and if it's found in word indices, we're going to bring it to 1. And then we will just return featurevec. Alright, so now all our functions are done. So let's test featurevec on all of our data. So basically, okay, we'll get this ready. We'll get our vocabulary here. We don't need this anymore. But okay, let's clean this up a little. Looks good. Okay. Get rid of that, and that. Alright. So, okay. Get rid of this. It's going down here. Alright. After vocabulary, what else do we need? We need to process all of our emails, right? Actually, not really. All we have to do is plug our emails into getVocabulary, and getVocabulary will process them for us. Okay, so emails is going to be, remember, okay, look, data looks like this, right? This is our emails. So emails is the column of data called v2, and it's going to be a data frame, but let's convert it to a list, right? .toList. So there we go. We'll put that in right in here. Now we have a list of emails. And we're going to create, okay, first we're going to process all of our emails. So emails will be, basically we're just going to map process email to every element in emails. So process email of some email x, and this is going to be a lambda function, which takes an email and gives back its processed form. And then we're going to map that function to emails, and then turn it back into a list. Okay, so now if we run that, let it finish. It's gonna take a second because it has to find the vocabulary and the emails. All right, and now we check emails. Okay, so you can see each email is a list of words processed, and you can see this is one email, this is another email. You get the idea. All right. So now that that's done, we're going to create our feature matrix X. This is going to work like this. We're going to get the indices, of, okay, we have to get the indices of every email. So we're going to use another lambda function, call it little x, for each element of emails. So for each email x, we're going to get the indices. We got to pass in the vocabulary there. So this is going to be the indices of a given email. Then we're going to get the feature vector. Oh, sorry. Right, okay. Get feature vector. And we're going to pass in the indices for that email into feature vector. And feature vector takes a vocab length, which will be, we can do it like this. Vocab length equals 2000. Okay. So we pass it vocab length here. And so what this is saying is we're going, for a given email x, we're going to find its indices, and we're going to construct the feature vector given those indices and the length of the feature vector that we want. And so with that, we're going to map this. So for each email, we're going to get a feature vector. Okay, so we take some x, which is an email, and we're going to return its feature vector. This is a lambda function, and we're going to map this lambda function to every email in emails. Okay, and then once that's done, we'll just convert it back to a list, and once that's done, we'll convert it to a data frame so we can view it again. And before we convert to a data frame, we will why won't this work? Should work. Oh, we want to change the data type. So instead of using floats, we'll use integers because all we're doing is 0 and 1. So numpy dot, well, we would do x dot as type, np dot int16, but this as type only works for numpy arrays, so we'll turn it into a numpy array first. So we turn x into a numpy array, convert its type, and then turn it into a data frame. Oh, right. Alright, and after all our work, take a look at x, and there we go. Each email on an index here, right, there's 5,572 emails. For each email, we have a value for whether a given vocab word, these are the vocab words, is present. So for example, in email number 2, we can see word number 1 is found, word number 2 is found, and word number 4 is found. So if we look at our vocabulary, Word number 1 is a number. Word number 2 is the word to. And word number 4 is the word So all three of these words are found in email number 2. And if we take a look at email number 2, we can see there it is, and where's there it is. So this is showing us which vocab words are present in which emails, and this will work as a very fine input to our learning algorithm. So we are ready to train. Y is going to be, if we take a look at data again real quick, you can see Y, this is our Y right here. So Y equals data sub v1. Okay, so there we go. Our X looks like this. Our Y is just a vector of classifications of spam or not spam. And then we're going to create, we're going to do a train test split. X train, X test, Y train, Y test. It's going to be train test split of X and Y with a train size 80%, which should work just fine. It's a huge data set. I mean, for what we're doing. Okay, so we'll split it, and that'll shuffle our rows as well. And then we'll create a model, which will be a support vector machine, support vector classifier. And we will fit our X train and Y train. So let's let that run. And we'll see how it does with the model.score. Now, like I said earlier, score is not going to give us so much information because if we take a look at this, Y is just an array of zeros and ones. So if we take the sum of the whole column here, it will be the number of positive examples. So if we do numpy.sum of Y divided by the total number of elements in Y, we'll get the percentage of positive examples in our data. And it's only 13%. So 13% of our emails are spam, and the other the rest of them are not spam. So we have skewed classes here. So accuracy, let's see how it runs. %98 accuracy, but doesn't tell us much because no, it's not bad because we still have 13%, but we get a much better understanding of how the model's behaving if we use the F1 score metric. So we'll make a array of predictions, Y predictions, model.predict, X test. So this will be our predictive values, and then Y test is our actual values. So we will say we'll find the F1 score, which we imported from sklearn, of Y test and Y predictions. And we get 93%. This is very good. We were 93%, well, it's not exactly a percent, but it's an F1 score, which means, this is performing very well. We're very good at classifying if an email is spam or not spam. So, thank you so much for watching. This has been a wonderful video. If you liked the video, make sure to subscribe and leave a comment below if you have any recommendations or just want to let me know how I'm doing. So enjoy, have a good day, and I'll see you tomorrow.